Hi everyone, welcome to this session. Lean, mean, green machines, architecting for a greener future. My name is Sara Bergman, and I've been talking about these subjects for quite a few years now. And when I first started talking about these subjects, I would typically start my presentation with a slide like this, showing the global average temperature. This is data from NASA, by the way. Or I would have shown something like this, showing the CO2 concentration in our atmosphere. However, I am done talking about the problem. There are other people who do that much more eloquently. I want to talk about solutions. And I assume that because you came here, you also want to talk about solutions. So that's what this talk will be about. It will not be about climate change, but it will be about solutions and our collective future. Like I said, my name is Sara Bergman. I am a Swede living here in Norway, which means I am fluent in svorsk, which is this glorious combination of Swedish and Norwegian that no one fully understands, but it flies in both countries. I am a senior software engineer at Microsoft, where I work with Microsoft 365 products. I'm also an individual contributor at the Green Software Foundation, where I've been around for, LinkedIn told me, 3 years, apparently this week. I'm also an author of the newly released O'Reilly book called Building Green Software, and I actually have a few copies with me here today if you would like a signed copy after the talk. Great, so the question becomes, where are you now? And I don't mean you as an individual, but as an organization. Where are you on your journey to a greener tech future? And one way to assess that is using a maturity matrix. The Green Software Foundation have a great one. It's called the Green Software Maturity Matrix. The Green Software Foundation, in case you haven't heard of them, they are about 3 years old, and they are a non-profit foundation under the Linux Foundation, whose goal is to build a trusted ecosystem of people, tooling, standards, and best practices. One of those things is the Green Software Maturity Matrix. Now, maturity matrices are not new. They've been around for a long time, and they've been used in various industries to assess how your organization is doing compared to the industry best practices and how you can advance up that ladder. And the Green Software Maturity Matrix specifically is about assessing a tech organization's capability of handling the energy transition. It has 5 different levels. Level 1, aspiring. This is where you're sort of floundering. Processes around this are unpredictable, they are poorly managed, and they are typically reactive. You maybe have some people around your organization doing isolated bits and bobs here and there, but you don't have a systematic interest or no systematic processes to govern this. Maybe some development teams measure their carbon emissions, but overall you don't really know what you're doing. Level 2, aware. Now you at least know your organization's Scope 1 and Scope 2 emissions. You have a few projects that's actually actively driving greenness, and not just driving greenness, but the data you get from those projects are getting put into use. You're still often reactive though. It's not much thinking ahead here. On level 3 though, acting. Now you're starting to find your groove. You're good at this. You have decent, basic, org-wide tech data and knowledge, most importantly. You are starting to have these defined processes for how you gather data and what you then do with that data to improve. Level 4, awesome. And now your processes, they are measured, they are controlled, you are in control of where you're going, and you can measure your progress towards your carbon goal dynamically, which means you have real-time data to track your emissions. And you're actively driving down not only your own carbon footprint, but that of your customers as well. Lastly, level 5, inspiring. You're running ahead of the pack. You have continuous improvement that's based on qualitative data and quantitative feedback. You have team-level measurable goals on how you're going to reduce your carbon footprint. Maybe they're OKRs, maybe they're something else. and you are optimizing everything for minimizing your CO2 emissions using dynamic real-time data. This is the full matrix. So you have the 5 different levels at the top, and then you have 9 different categories. So you have climate commitment, carbon footprint, metrics, carbon ops, energy, devices, utilizations, product, and training. We're not going to dive into every single cell here because there's a lot, and the talk is not about this matrix, even though we will use it as a tool. And you may think that, okay, yeah, this is a great tool. This will teach me how to be ethically good, how I can get a gold star at the end of the day. I'm doing climate stuff. No, this is not what this tool is about. It's also about being ethically good. Of course, it is ethically good, but that's not why the tool exists. The tool and the purpose of moving up those ladders is a risk mitigation strategy. It is to provide resilience to your organization towards a bunch of things that are currently happening. And that's things like tightening environmental, societal, governance, and things like EU reporting requirements around sustainable IT. It is to provide resilience against disruptions to IT systems that are caused by extreme weather events caused by climate change. Also things like pricing changes. We're seeing electricity is increasingly dynamic in its pricing. It is to adapt to the upcropping reduce, reuse, recycle rules and laws that are coming across the globe. And it's also about hiring and retaining employees. For my generation, and especially the ones coming after me, this is very important. They consider it very important to work for an organization whose values match their own personal values. And that is a risk if you want to retain younger talent. So we know that the GSMM is a risk mitigation strategy. We also know that almost all of us are on level 1, maybe level 2 right now. We're sort of floundering. There is very little systematic interest in this across our industry. And the reality is that we need to be a lot higher kind of fast. And going to level 5, that inspiring running ahead of the pack, that is a very long-term project. It's going to take significant investment to get there. So sadly, this talk will not give you the magic tools for how you can propel yourself from level 1 to level 5 before the next NDC. Instead, I will talk about actionable things that you can do that will get you towards level 2 and level 3. And before we go there, it can be useful to note that there are 9 different categories. You can be on different levels, on different categories. We're seeing some organizations that are already on level 4 in some of those categories, or maybe a bit further behind in others. Fantastic. Where do we begin then? If you're a software practitioner, you may be an engineer, maybe an architect, maybe you're a manager, maybe you're a program manager, and you want to help move your organization up this ladder, where do you begin? Maybe you think, code efficiency. Surely, if we just write more efficient code, problem solved, done deal. Especially if your code base is written in like your non-favorite language and your favorite language is actually highly efficient, then it's very convenient to suggest this as a first approach. And of course, we're not going to deny that code efficiency can have massive gains. Like if you write more efficient code, we know that that has massive impact. That impact is not guaranteed, and it can also be at odds with other things. Because writing highly efficient code, that's hard. It takes a long time. Increasing development cost and time, decreasing developer efficiency. And whether you like it or not, developer time is very expensive. It might be the most expensive thing your company spends money on. Therefore, it's very important to them that that time is spent wisely. And that can tip the scale in a direction you don't want to go. So writing this highly efficient code may never be worthwhile if your product doesn't have enough scale. Efficient code is also difficult to maintain. It requires specialized knowledge, and it makes it harder to evolve this code in the future. Any serious performance talk at any conference will tell you this. Tread carefully, there be dragons. They will tell you, these are all the cool things that you can do, and then they will say, please only do the ones that matter to you. Don't blindly implement all of them in your code base, because they will make it impossible to understand what your code base is doing. So if code efficiency is mission critical for you, if you have a high performance computing scenario, you're already doing this. You don't need me to tell you, oh, by the way, it's actually also greener. You know that. If code efficiency is not mission critical for you, it is likely a very bad place to start if you're on level 1 and you're just trying to move up the ladder. So of course, always do the small efficiency improvements, but please don't rewrite your entire code base as your first step to be greener. Okay then, so if it's not coding, maybe it's data center efficiency. Surely that matters a lot. And it does. It matters greatly, which is why a lot of smart people for a very long time in very many different companies have been thinking about this and working towards that for a long time. We're starting to see the new hyperscale data centers that come out now. They have a power usage effectiveness number of 1. That number is called a PUE. And that basically means that it's a ratio. So any electricity that goes into a data center, it measures how much goes to meaningful compute and how much goes to auxiliary things. And if your number is 1, that means all energy that goes in goes to meaningful compute. Fantastic. We're close to those super efficient data centers. However, that doesn't really matter if that meaningful compute is actually wasteful compute. So cloud users are still responsible for the sustainability in the cloud, not off the cloud. So what you can do is, of course, use your spending power. Find a provider, if that is a cloud provider or another data center model that works for you, where they are aligned, they are on the same journey, they are also committed to being greener. So, but it's not the end of the story. We're not off the hook. So, well, where should you start then? I argue that you should start with architecture. You should start thinking about operational efficiency. It is a very worthwhile effort. Firstly, it's entirely within your control. You have to change very little to have potentially very big impact. And you don't have to wait for anyone else. You don't have to wait for this magic carbon neutral negative hardware running on like clean water. I don't know. You don't have to wait for significant technical improvements in our area to start being greener today. These are things that are already available. And not only that, if you improve the sustainability factor of your architecture and how you operate, you will almost always end up with a cheaper, more performant, and more resilient service as well, which is great when you're trying to persuade someone who might not be persuaded simply by the greenness. So what makes software green then? Perhaps that's a good way to start. Well, carbon efficiency is this overarching term. Use the least amount of carbon possible. That is the definition I will use in this talk. There are other factors that play into sustainability, like land usage, water usage, or waste management. They are very important, but we will not talk about them today. You can also, of course, build software for greener purposes. Software can be this fantastic accelerator for other industries to help them get greener. And that's awesome, but that's not what we're talking about today. So carbon efficiency breaks down into these 3 sub-areas. It's energy efficiency, so use the least amount of energy possible. It's hardware efficiency, use the least amount of embodied carbon possible. And here you may think, stop, I am a software person. I don't have to care about hardware. I surely am off the hook here. Sorry, but software really impacts the type of hardware that you need and the type of hardware that your clients need to run your software, so you're not off the hook here. And lastly, carbon awareness, doing more when the grid is green and doing less when the grid is dirtier. And I mean the electricity grid here. And that helps to decarbonize our grid now and also going forward. How does that relate to operational efficiency then? Well, it really boils down to these 2 concepts, energy proportionality and the machine utilization. Nothing super fancy, but I think this graph kind of shows it well. And please, the numbers are just fake. Don't write them down. They're just to have like a numbers example. But machine utilization matters for 2 reasons. The first is the energy side. Switching a server on actually costs a lot of energy. An perfectly idle server and doing nothing except heating its immediate environment burns a lot of energy. So you want to be mindful of that cost. Any additional electricity is consumed sort of scales with utilization, not like perfectly, but it sort of scales with utilization. But that additional cost is a very significant portion of the end energy cost that you pay. So you don't want to have like 10 servers utilized at around 20%, or sorry, around 2%, because you're paying that startup cost on every single server. Instead, you want to have one server utilized at 20%. So having adequately utilized servers is important for energy, but also it is important because it's more efficient in how you use your hardware and how much hardware that you need. If you have 2 servers like with low utilization, you maybe can't use them for other things. Instead of having one right-sized or rightfully utilized servers, well, that other servers suddenly freed up. You can do other things with it. Fantastic. So keep this in mind, because this is the baseline of a lot of what the recommendations are based on. I also want to talk about the energy market, because the energy market right now is really fascinating. And the electricity market, it matters for software for 2 primary reasons. The first is the graph you see to the left, and that is the carbon intensity. Different ways of generating electricity costs different amount of carbon. Right now here in Norway we have hydro. Very clean, very green, as you can see in the graph. It's very little carbon per kilowatt hour produced. Other countries still have a lot of fossil fuels in their energy generation. Now, that's much less green. That emits a lot more carbon per kilowatt hour produced. The second part of the electricity market that matters to you is the pricing. And the price of electricity fluctuates, and it depends on a series of different factors. The most important one, at least for the purpose of this context, is that supply always have to be met by demand. If we have an excess of electricity on the grid, a lot of very expensive things break. So what they do instead is just dump it on the ground. If there isn't sufficient demand, it gets lost. We are not great at storing for many reasons. So therefore, prices vary. There are times when there are such excess of energy available that you as a consumer might actually be paid to consume that energy because it's cheaper than if they just have to dump it on the ground. Secondly, the price is, of course, depending on what does it cost to generate this electricity. Maybe some kind of fuel is needed. Maybe some kind of transmission cost had to be paid. The weather impacts as well. If it's very cold or if it's very windy or very sunny, those things matters as well. And as with any commodity that has a variable price, people will trade on it. So that's the graph on the left. It's from Nord Pool, showing how energy is traded in the north of Europe. But the truly cool thing about the electricity market is this. Grids are getting greener around the world. The electricity market is in the process of being revolutionized. This always available, always on fossil fuel electricity that is being replaced by low cost but variable renewables. We see more and more countries all across the globe that have low carbon electricity for longer periods of time. Some of these countries even have free electricity for parts of the day or parts of the year. And this is largely thanks to renewables. Now, the thing about renewables, things like solar, hydro, wind, they are more spiky. They have more variability in the supply of those. And we can compare that to fossil fuels where, well, you can just shovel more coal into your coal plant and it will just produce more electricity. You don't have to care about if the sun is shining or not. And batteries and nuclear, which is low carbon, even though it's not renewable, they can provide a degree of buffering to that spiky variability of renewables. But they will add significantly to the cost of electricity because, believe it or not, it costs a lot of money to run a nuclear power plant. So, going green, it's not just about like battling climate change and, again, being ethically good, but it's also about adapting to this new world. This will happen, this is already happening, whether you like it or not, whether you believe in climate change or not, this is going to happen. So systems that can use demand shaping and demand shifting and can adapt and run on low carbon electricity, they will have far, far cheaper power. It will be a big monetary difference. So companies that can make use of this, they will win. Okay, that was enough about the electricity market. Going back to software, what can you do? So we're going back to look at the maturity matrix. I think that these three categories are extra interesting to look at for architecture scenarios. It's carbon ops, energy, and products. So we will focus on them. Also, I read all of the major three, so AWS, Azure, Google Cloud's well-architected frameworks and their sustainability sections, so you don't have to. I just summarize what they say. I will sprinkle that throughout the talk as well. Fantastic, let's dive in. Let's talk about carbon ops, server resource management. It's more fun than it sounds. Firstly, I want to tell you to don't be Smaug. Now, Smaug is a dragon in the movie The Hobbit, also in the book The Hobbit, and he lives in a mountain in this great treasure pile. He does not share the treasure. Absolutely not. He also doesn't do anything with the treasure. He just sits on it and hoards it. And you don't want to be Smaug. You want to delete unused idle resources, old logs, unused data. Any kind of zombie workload that you have, they're just walking around doing nothing useful, eliminate it. And it's a great way to save cost, of course, on-prem and in the cloud. But it is also greener because you're using less resources. And that's very easy to say. It took me almost no time to write this slide. It is harder to achieve, of course, because in the end, no one really wants to not do this. Like if you have a server that you know or a resource that's doing nothing useful, like you're not keeping it around just for the sake of it. If it was easy, you would have gotten rid of it. So how can you orchestrate this? It is a technical problem, but the solution is both technical and org-wise. Very simple one is just retention policies. That's a good way to go. FinOps is another. Follow the money. Where are we spending money? Another very exciting idea and a lens to see this problem and to craft the solution is light switch ops. It's this fantastic ops that was coined by Holly Cummins at KubeCon London last year. And it's the key thing here is it should be as easy to turn a resource on and off as it is to switch a light on and off. Because when you leave a room, you turn the light off, you leave, and you feel confident that if you need to go back into that room, if you need the light to come back again, it will. The switch will still work, electricity will still be there, the light bulb will still shine its light. Resource management should be just as easy. So that is a guiding principle. A key part of that is you need to make it easy to give people what they want. Say I need some kind of test environment because I need to test something, I need to set it up, and it's a really complicated process. I had to maybe fill out the form, and then I had to wait for someone to approve the form, and then we had to go back and forth, like, do you really need it? Yes, I do. And then eventually I got this test environment, and I ran my test. It took me just a day. There's no way I'm releasing this test environment. I will keep it forever, because maybe in a month, in a year, I will use it again. Maybe I won't, and maybe I'll just sit completely idle until then, but I worked so hard to get it, so I will not release it. Sorry, but that's just the way it works. So that's an anti-pattern. You want to make it easy for people to get what they want, because that makes it easy for people to delete what they don't want. Another thing you want to think about is to decouple storage and compute. You want to use services available to decouple your compute and your storage. Because if you have to maintain a very large infrastructure process for storing your data and you have to scale that same infrastructure for your peak compute use, which only happens, surprise, at peak, most of the time your resources will sit idle because peak is such a short period of time. And if they're idle, you have more cost and you have more emissions. And this is just some Google examples of solutions that you can use to decouple. Another thing you want to think about is to use the most suited technology. Don't treat storage as one size fits all. So for storage techniques, you want to think about what can best support the data that you're actually storing. And that helps you to reduce the required, like if you're in the cloud resources that you need, and improve the overall energy efficiency. So this is some AWS example. If you have Archive, you want to think about Glacier. If you have Key Value Store, maybe DynamoDB is right for you. You want to think about like this hot, warm, cold scenarios, for example. Backup is another interesting data storage thing. Now, backup, we know, is a crucial part of reliability. But you only want to store what is relevant for as long as it's relevant, because storing backup indefinitely can quickly allocate much disk space which you're not using. So consider how you plan your backup storage retention plan. And for example, on Azure, you can use Microsoft Purview to label data and add time-based purging. I apologize for my graphics. I am a backend engineer. This is the best I can do. But yeah, this is a container that's not right-sized. This is a container where your resource use is much smaller than what you could possibly fit into your container. So you have a lot of wasted capacity there. Instead, you want to do this. You want to right-size your resources to your resource need. You don't want to, just in case, take the bigger one, because maybe in the future it will, don't do that. Think about right-sizing. That saves energy due to energy proportionality, because suddenly I could fit another container on the same server. So I'm using that startup cost of the server more effectively. Also, I'm using less hardware, because if I had these two oversized, then I would have 2 physical servers instead of just 1 physical server. And that saves, I mean, if you already have the 2 servers sitting in your server hall, it doesn't save much right now. However, it saves in the future, because capacity planning, no matter if you have a local on-prem data center or if you're on a cloud, it's a very long-haul process. We know our industry is growing. It's always been growing. Also, machines get old and get decommissioned, so you have to constantly plan for capacity. How much servers will I need in the future? And you can have like a finger in the air and guess. You're not going to be very successful. So typically what people do is look at, okay, how has usage been growing? What am I doing right now? And how do I expect that to scale? And that takes a long time, because it takes a long time to create a server. Also, we have seen in the past that there have been periods where we have chip shortages, for example. We saw that during the pandemic. It took a very long time because the logistic market was kind of jammed. So yeah, capacity planning is long term. So what you can do is to send the right signals. If you're constantly over-provisioning, constantly asking for more than you actually need, well, the signal you're sending to your local center or to your cloud is more. I need more. There is not enough. However, if you're always right-sizing, the signal you're sending is, this is how much I actually need. This is, then they can base their trajectories on something that's actually grounded in real truth. And over time, together, we will right-size our industry. In addition, this is almost always cheaper as well. Again, this is easier said than done. I want to say it was very fast to create this slide, but again, I am a back-end engineer. I worked really hard on this. It can be tricky to understand the sizes you need. I first wanted to have a slide that showed like all the different instance types from all the cloud providers. There was no way it was going to fit on a screen. Like, there's so many. So I understand it's a lot of analysis to right size. It's not something you just do 15 minutes before stand-up. But one way to achieve right sizing is auto-scaling. Now, this is the same graph as before, but I added demand and a right-sized container. So with auto-scaling, you can do vertically, but it's a bit trickier, so I chose a horizontal scaling example, is that you want to scale the amount of resources that you use after demand. And we are, as an industry, pretty much on board with this idea. It's nothing new here. We're pretty good at the first half as well. Like, we're sitting there, utilization is pretty good. Oh, demand is increasing, and then we just throw more stuff at the problem. The thing is, the other half is just as important. Otherwise, auto-scaling really only works the one time. So you want to be able to scale down as well. And many cloud providers have good support for this already on many different kinds of workloads. This pattern is great if you have a variability in demand, which is very common. Most people maybe have customers that are located in one geographical area, and then when there's night, well, you have less demand, for example. If you get auto-scaling right, it's also a great way to achieve higher levels of resilience in your service. Of course, this doesn't automatically happen on itself. You need some kind of way to orchestrate that, like a cluster scheduler or infrastructure as code, or many cloud providers, like I said, already have support for that. Okay, So I mentioned cloud a few times. Let's talk about some cloud-specific things you can do in terms of carbon ops. And cloud isn't magically better at being greener. They are better at being greener because they're interested in being efficient, because it's cheaper. Like, it's very costly to run very large data centers. And they also have a very varied amount of customers, which means that they can do a lot of smart things in how they pack software onto physical servers. That's the business model of the cloud, essentially. So yes, what things are specific to cloud here? First, I want to lift up serverless containers, or serverless in general. That's being pushed very heavily by all cloud providers. And this is when you can have like software without the infrastructure. That's like the selling pitch. And I like to think about it as a way for you to help them help you be greener, because this way they can manage the servers so that they can optimize the cloud resource use, which is like for you done automatically, for them done with some very smart code. And that reduces your costs, but also your carbon footprint. Serverless, of course, isn't magical, but the cloud have the financial incentive to spend developer cost on solving that problem. They can afford to spend time to think about these problems. Okay, how do we pack these varied amount of resources, varying amount of needs onto physical hardware? Your primary business is likely something completely different, so you might not have the resources to spend on that thinking, and that's okay. But that is why it's better. But it's not always, of course, magically better. There are very few things in the world who are magical. Maybe some would argue nothing is magical, but I'd like to believe there's some magic in the world. Anyway, as an example where it's not better. Say you have a full-blown Kubernetes orchestrator, but you're running a very limited amount of containers, or they're not doing much at all. Then the overhead you're going to have from running the advanced Kubernetes orchestrator might be way more than you actually save if you just did it by yourself. So yeah, these are some examples of serverless things that you can use. And I saw that there's several other talks this week as well, so if this is super interesting to you, go to those talks. Another cloud-specific thing is that on the cloud, you have a choice of hardware. And you want to utilize the fact that you have a choice. You want to use the most efficient hardware. Because correctly choosing here means that you can reap a lot of benefit from what hardware providers have put into making efficient hardware. But you don't have to purchase it. You don't have to make this long-term capacity bet. You can just choose because it's already available. And this can be like AI accelerators, it can be different CPUs, or sometimes the cloud providers also have their very own hardware. Most of the time, the gain here is not on the embodied carbon, because most hardware is, like, there is few things who are dramatically cheaper in terms of manufacturing cost, but what you save here is energy efficiency. And when you save on energy efficiency, it means you can be smarter and do more with less, basically. Some example here is the AWS Graviton. It's a family of processors. They say it can give up to 40% better performance for a variety of workloads, which is nothing to sneer at. The Azure's Ampere Ultra ARM, it's a complicated name to say. They are also CPUs and have very low power consumption per core. So again, less energy consumption. Or Google, they have a tensor processing unit. That's a custom ASIC that Google built specifically for machine learning. And they saw like an order of magnitude better performance per watt for machine learning. So using more efficient hardware can mean you save energy. Of course, speaking of cloud, I have to mention the Cloud Native Computing Foundation's TAG, Environmental Sustainability. TAG stands for Technical Advisory Group. And this TAG, they have a goal to advocate for, develop, support, and help evaluate environmental sustainability initiatives in cloud-native technologies. They have a few different projects. They have one for best practices for sustainable Kubernetes clusters, and they have another project for assessing the carbon footprint of other CNCF project. So if you're already like in the sphere, you're already working with them, definitely check out the work they are doing. Right, I mentioned efficiency a bunch of time now, and typically when I do, someone always says, but what about Jevons paradox? So let's talk about Jevons paradox, shall we? Now, if you're not familiar, it's the historical observation by a dude called William Jevson that when we get more efficient at doing something, it gets cheaper. And in the long run, we will then end up doing more of it. So it's like efficiency eats its own gains over time, basically. And historically, that's been true. It is not really a paradox, but an observation in many scenarios. And the key thing that makes it different in this scenario is the energy transition. And here I am a tech utopian. I believe that in not so far future, we will have clean, abundant energy available for all. It's not super far away. We are already going towards that future. And it's not going to happen now, though. It's still a few years in the future. And once we get there, it doesn't matter if building efficient software is something that causes us to build more software, because we will have this free, abundant energy, so we can afford to do it. But we're not there yet. And until then, we need to be better users of energy. We need to do more with less. I don't believe these two will end up in a race, because doing something like massively more efficient, it's very hard. It's very costly and it's very time consuming, and none of the things I'm telling you today will make it massively more efficient. Like, it will make it more efficient, but not so much that we really truly step into the problem of Jevons paradox here. So in the long run, I think we will, as a community, sort this out, thanks to the amount of renewables that we're putting on the grid. All right. The next category on the Green Software Maturity Matrix is carbon-aware energy resource management. Now we have to go back to thinking about the grid and thinking about how energy generation from different sources releases different amount of carbon in different places. Also, this works around the clock. Energy generation in Norway, for example, is always hydro. It's the same in the day and the same in the night. But in many countries, this varies over time. You maybe have solar in the day and you maybe have something else during the night hours. And time shifting means you're using this variability. You're moving your workload, something that's not on demand, to a greener time. And this works because there are multiple different APIs available right now that can provide a forecast of the carbon intensity of your grid for the next 24 hours. And to make use of this, you need the API call, and then you need some tools on the ops side, so like a burstable, flexible, spot instance, depends on what type of provider you use. And it's nothing more to this than like a fancy scheduling problem. We are pretty used to schedule software to run based on something. Think of this as a different signal that you can use. And in addition, with the energy market being what it is, this can end up being way, way cheaper as well. Having a workload that's able to do this will make it more resilient over time when we will see an increased variability on the grid as well. It's nothing fancy, like I said. Big tech has been doing this for a long time. Google's media processing for things like YouTube, they have been utilizing this pattern since 2001. The sibling to this is location shifting, moving to a greener place. Now, this doesn't work for all workloads. It's suitable when you don't have a lot of network cost and when privacy allows for it. So you don't want to move like a European workload across the Atlantic, because according to European law regulations, that might not be allowed. Also, if you have something that's going to interact a lot with your database that's in a different country, well, you're going to end up spending a lot of carbon on the network. So think about when you can do this. But that region doesn't have to be across the Atlantic. It can be within your same country. Many countries today have different energy sectors, I would say, within the same country. Or it can be the neighboring country. So you can ask your cloud provider, if you're under cloud, hey, what is the greenest region that works for me? Or you can use tooling. But before we talk about tooling, we need to distinguish, because there is something called the greenhouse gas protocol. It is incredibly used by not only our industry, but a ton of different industries to assess your carbon footprint. There could be a whole talk about this protocol in itself, and I think it's fascinating, but I'm going to try to keep it short. So in short, what they call Scope 2, that is your indirect emissions that are caused by your energy consumption. So typically the electricity that you use. They allow for you to report this in two different categories. The first is the market-based, and the second is the location-based. In the market-based reporting category, you are allowed to talk about market incentives that you're taking. For example, maybe you, through a power purchase agreement, are investing in an offshore wind farm. Now, that energy might never ever reach your grid, but you are doing net good for like the environment. It can also include things like carbon offsets. So maybe you're planting trees in a completely different country. Again, those trees are not going to eat like your specific molecules of carbon dioxide that you emitted. Like that's not how it works. But again, you're doing net good. The location-based is much simpler. It just tells, okay, what energy are you consuming from the grid and account for that. I don't want to say that one is good and one is bad of these, but I do want to say that for software, I find the location-based much less confusing because it's simply when and where are you running, and you don't have to think about much other things, so it's just easier. But for location shifting, you can still bucketize them according to these two reporting standards, because also your organization might already be using it, and then it's important to know what they're using so that you can map to what they're using. But yes, so in the market-based category, you have things like AWS's Renewable Energy Project webpage. That's a page where you can see where they're spending energy and money into renewable projects. The Google Cloud Region Picker also have historical data per region where you can see where they spent, which regions are the greenest, were the greenest for them. AWS and Azure's emissions impact tooling both provide this data on a very granular level specific to your organization, specific to whatever you're running. On the location-based side, we have the Google's emission impact tooling, and we have 3 open source and non-vendor locked-in options that are electricity map, WhatTime API, and cloud carbon footprint. Okay, so let's move on over to product. And that is carbon-aware product management. So far, we have not really talked much about product. We have talked about things on the backend side, really. For product, again, you can also make use of this variability we have in the electricity grid through something called demand shaping. Like I said before, the electricity market is changing. Variable energy will change the cost of energy and availability of energy as well. We, if we're using a data center, might not today feel that immediately, but our customers who are like in their own homes, who pay their own energy bill, they certainly feel that. They definitely felt it during the energy crisis a few years ago, and they're definitely going to feel it in the future. So thinking about this can be a win for them as well. Going green means adapting to this world. It means that you are changing the behavior on the product side. When there is more clean energy available, you do more. And when there is less clean energy available, you do less in your product. And you can either let your customer choose, do I want this or do I not want this? Or you can decide for them, I think this is best for you. I like to use the example of a washing machine. Now, I don't know a whole lot about washing machines, but I have one, and there's an echo program. So I push the button when I run on my washing machine. Now, I assume it's going to use less water, less electricity, but I don't really care like how it achieves that. It's just sort of something I don't care about because I don't make washing machines. And like it or not, but that's how many of our customers feel about software. They don't really want to know how it works. They just want it to work. And if there was a button they could press for an echo mode, a lot of them might press it because they also want to do their bit. So this might sound a little sci-fi, changing the behavior. What does that mean? There are already products out there that are effectively utilizing this. I chose 3 examples here. So the first to the left is the Climate Action Tech's magazine, which they publish a year, called Branch Magazine. What they do is they check how green is the grid of wherever you are reading this online magazine, and then they adapt how the magazine is produced. So for example, if you have a very dirty grid, there is mainly only fossil fuels on it, you might not see photos, you may see a text description of the photo. Maybe you're here in Norway, you have hydro, and then you get an HD version of the very same photo instead. The one in the middle is iPhone. They have something they call clean charging, which you, again, can switch on and off. And when you plug in the charger, your phone will receive a forecast of the carbon intensity of the grid where they are connected for next time, and it could choose, okay, maybe I charge in a little bit, or maybe I charge now, because right now the carbon intensity is super low. Xbox is doing the same for game downloads and update installs. Now, they don't push this indefinitely, of course. That wouldn't work for anything to say like, oh, I will never charge because you're constantly in this high carbon area. No, it makes a reasonable assumption of what is this time period. But again, it doesn't matter to me if the update always comes at 2 a.m. at night, or if it comes sometimes between 10 and 6 a.m. As long as it happens, and if it can be done greener, I am, as a consumer of that product, is happy. So we went through the Green Software Maturity Matrix. We went through the 3 different categories. We saw some examples from cloud providers. Where does this all take us? Well, we know that all of these actions, they will help your sustainability to go up. They will advance you on the Green Software Maturity Matrix ladder. But they also have co-benefits. Cost will go down. You will end up with a cheaper service when you have higher machine utilization and when you have lower energy cost. Resilience will be higher as well. Things like auto-scaling and carbon-aware actions, they are a great way to today future-proof your software. So the key learnings here is that software will benefit from carbon efficiency. It means adapting to this new reality of a greener grid. We also know that building green from the start is cheaper, more performant, and more resilient. I have some resources here in case you are interested. And other than that, thank you for listening.